Good morning, everyone, and welcome. I'm delighted to have you here today. Today, we'll be exploring the important topic of calibration of equipment. This presentation will cover the essentials of calibration, its significance, and best practices to ensure accuracy and reliability. We'll go through the key concepts and practical tips that can help you maintain your equipment effectively. Let's get started and make this session both informative and engaging. Let's talk about the calibration of measurement instruments. Calibration is essentially the process of comparing a measuring device with a trusted reference standard. The goal here is to evaluate how precise the instrument is and, if needed, to make adjustments to ensure it meets the required standards. This process is really centered around two key performance parameters: accuracy and precision. According to ISO, calibration isn't just a simple check. It involves a set of procedures that establish a clear relationship between known values of the measurand, the quantity we're measuring, and the readings our instrument indicates under specific conditions. It's important to realize that the measurand isn't just a single number. It's defined by a set of requirements. These include all relevant factors that could influence the measurement. Specifying these factors in detail is crucial so that uncertainty doesn't compromise the calibration's accuracy. The main objectives of calibration are twofold. First, to determine how accurate the measurement is, and second, to ensure that our measurements are traceable to recognized standards. This traceability is vital for maintaining consistency and reliability across different measurement systems, especially when quality and compliance are on the line. Calibration is a crucial part of maintaining our measurement instruments. It helps ensure that the results we get are reliable, consistent, and accurate. Over time, though, instruments can drift due to wear and tear, environmental factors, or just regular usage. That's why periodic calibration is so important. It keeps everything in check and guarantees our measurements stay trustworthy. The key reasons for calibration are quite straightforward. First, it ensures the accuracy and reliability of our data. Without proper calibration, our results might be off, leading to incorrect conclusions. Second, it maintains consistency over time, so measurements taken months apart are still comparable. Third, calibration provides traceability to standard reference measurements, linking our results back to recognized standards. This is essential for quality assurance and regulatory compliance. It also helps us detect and correct any instrument drift or errors before they affect our work. And ultimately, calibration boosts our confidence in the measurements we rely on for decision-making. When it comes to quality and compliance, calibration isn't just a good practice. It's a necessity. It's the backbone of trustworthy measurement systems and essential for achieving high standards in our work. Now, let's take a closer look at the benefits of calibration. Calibration offers some critical advantages because it helps ensure that our measurement systems perform accurately and consistently across various applications. One of the main benefits is that it improves measurement accuracy and precision, which means we get more reliable data. This, in turn, enhances the reliability and consistency of our results, giving us confidence that what we measure truly reflects reality. Calibration also helps us stay in compliance with industry and regulatory standards, which is essential to avoid penalties and ensure quality. It reduces measurement uncertainty and errors, meaning our data is more trustworthy. This increased confidence in our data supports better analysis and smarter decision-making. It also plays a key role in quality control and process optimization, helping us identify where improvements can be made. An often overlooked benefit is that calibration helps us detect instrument wear or drift early, so we can address issues before they lead to bigger problems. And finally, it minimizes costs associated with faulty measurements or rework, saving us time and money in the long run. Overall, calibration is a vital part of maintaining high standards and ensuring our measurements are as accurate and reliable as possible. Let's talk about traceability in measurement. Essentially, traceability means that we can connect our measurement results back to recognized reference standards through a continuous, unbroken chain of calibrations. This chain must be documented carefully, with each calibration step contributing to understanding the overall measurement uncertainty. One of the key aspects here is establishing a link to national or international standards, which helps ensure that our measurements are consistent and comparable no matter where or when they are taken. Maintaining this unbroken calibration chain is crucial because it guarantees that our results are reliable and credible. This traceability not only boosts confidence in our measurement results, but also supports compliance with various quality and regulatory requirements. When measurements are traceable, it means they can stand up to scrutiny and be trusted across different systems and organizations. Now, why does all this matter? Well, traceability enables us to make reliable decisions based on accurate data. It also facilitates the global acceptance of our measurement results, which is vital in today's interconnected world. Lastly, it strengthens our overall quality assurance systems, ensuring that we maintain high standards in everything we do. Now, let's take a closer look at the different types of calibration. Calibration can be classified based on the method used, the environment where it takes place, and the standards applied to ensure accurate measurements. One of the most fundamental types is primary calibration. This is performed using the highest level reference standards, which provide the maximum possible accuracy. Think of it as the gold standard in calibration, setting the benchmark for all other types. Next, we have secondary calibration. This involves standards that have been calibrated against primary standards. It's a step down in hierarchy, but still offers high reliability, often used to calibrate instruments that don't require the utmost precision, but still need to be accurate. Then, there's working or routine calibration. This is what we do regularly for instruments used in daily operations. It's essential for maintaining consistent performance over time, ensuring that instruments remain reliable in everyday use. On-site calibration is another important type. As the name suggests, it's performed right at the instrument's location. This minimizes downtime because the instrument doesn't need to be transported elsewhere, which is especially useful for large or complex equipment. Laboratory calibration is conducted in highly controlled environments. This setting allows for very high precision, often used when the highest accuracy is required, such as in research or critical measurements. We also differentiate between static and dynamic calibration. Static calibration occurs under constant conditions, providing a stable baseline for measurements. Dynamic calibration, on the other hand, is performed under changing or real-time operating conditions, which is crucial for equipment that operates in fluctuating environments. By understanding these different types, we can better select the appropriate calibration method for our specific needs, ensuring our measurements are both accurate and reliable, which ultimately supports the integrity of our overall quality management system. Now, let's take a closer look at the parameters we need to calibrate. Calibration is essential because it ensures that the key measurement parameters of an instrument meet the required standards for both accuracy and reliability. When we talk about common parameters, accuracy is a fundamental one. It refers to how close our measured value is to the true value, which is critical for trustworthy results. Next, we have precision, which is about the repeatability or consistency of measurements. If we measure the same thing multiple times under the same conditions, we want our results to be very similar each time. Sensitivity is also key. It's the instrument's ability to detect even small changes in what we're measuring, which is crucial for detailed analysis. Linearity is another important factor. It describes how well the instrument produces a proportional output across the entire measurement range. Basically, we want the response to be predictable and proportional at all levels. Repeatability and reproducibility focus on consistency. Repeatability looks at the same conditions over a short period, while reproducibility considers different operators or environments, ensuring our measurements are reliable regardless of who or where. We also need to consider hysteresis, which is the difference in the output when the input is increasing versus decreasing. This can introduce errors if not properly managed. Lastly, Drift refers to the gradual change in measurements over time, which can affect long-term reliability. The main objective here is to ensure our measurement performance remains reliable, consistent, and accurate across all operating conditions. This way, we can trust our instruments to give us high-quality data, no matter the circumstances. Now, let's take a look at the various calibration techniques and methods we use to ensure our measurement instruments are performing accurately. Calibration employs different approaches depending on the situation and the level of precision needed. One common technique is the comparison method, where we compare the readings from our instrument to a known reference standard. This helps us identify any discrepancies. Then there's the substitution method, which involves replacing the measured quantity with a standard that has an equivalent value, making it easier to verify accuracy. The null or balance method is another important one. We adjust the instrument until the difference between its reading and the standard is zero, effectively balancing out any error. And finally, the direct method involves a straightforward comparison with a standard, without needing any intermediate steps, simplifying the process. Moving on to calibration methods, manual calibration is performed by trained technicians following standard procedures, ensuring careful adjustments. Automatic calibration, on the other hand, uses computerized systems, offering faster and often more precise results. We also differentiate between single-point calibration, which is done at one reference point, and multi-point calibration, where we calibrate at multiple points across the measurement range. This helps us achieve more comprehensive accuracy throughout the instrument's capabilities. The main objective behind all these techniques and methods is clear. We aim for high accuracy, reduced uncertainty, and ultimately, reliable instrument performance. This is vital for maintaining quality and confidence in our measurements, especially as they support critical decisions in our work. Let's walk through the process of calibration. First, we start with preparation. This involves identifying the instrument we need to calibrate, selecting the appropriate standards, and ensuring that the necessary environmental conditions are met. It's about setting the stage for an accurate process. Next is inspection. Here, we carefully check the instrument for any physical damage or environmental factors that might influence its performance. It's important to ensure everything is in good condition before proceeding. The comparison step involves measuring the instrument's output against a known reference standard. This helps us determine how close the instrument's readings are to the true value. If deviations are found during comparison, we move on to adjustment. This step involves correcting the instrument's readings to align with the standard. It's crucial for maintaining accuracy. After adjustment, we conduct verification. We recheck the instrument to confirm that it now provides accurate results after the correction. This step ensures the calibration was successful. Documentation is the next key step. We record all results, any deviations observed, the uncertainties involved, and the corrections made. Proper documentation is essential for traceability and quality control. Finally, we issue a calibration certificate. This certificate provides official proof of calibration, ensuring traceability and compliance with standards. The main objective of this entire process is to ensure that measurements are accurate, consistent, and traceable. When calibration is done properly, it underpins reliable data and quality assurance across all our measurement activities. Now, let's talk about calibration personnel and the vital role they play in our measurement systems. These individuals are essential for ensuring that our results are accurate, reliable, and traceable back to recognized standards. Their work involves following proper calibration procedures meticulously to maintain the integrity of our measurements. Key responsibilities include performing calibrations and making adjustments based on established standards and procedures. It's crucial that they ensure traceability, meaning their work aligns with national or international benchmarks, which helps us maintain consistency across different systems and locations. They are also responsible for properly maintaining and handling reference standards and instruments to prevent errors. Accurate recording and documentation of calibration data are fundamental, as this creates a reliable record of measurements and adjustments made. Identifying and reporting any instrument errors or deviations is also a critical part of their role, helping us catch issues early and maintain quality. When it comes to competencies, technical knowledge of measurement principles and the instruments involved is a must. Familiarity with calibration, standards, and procedures ensures they follow best practices. Attention to detail and accuracy are vital, as calibration is a precise science. Additionally, understanding measurement uncertainty and quality requirements helps in delivering trustworthy results. The ultimate goal here is to ensure high-quality, consistent, and compliant calibration practices across all operations. By doing so, we uphold the integrity of our measurement systems, which is fundamental to the overall success of our quality management efforts. Let's take a closer look at the calibration certificate and report. This document is an official record that captures the results of the calibration process and confirms that an instrument meets the specified standards. It's essentially the proof that your equipment is accurate and reliable. Key contents of this report include important details such as the instrument's model, serial number, and identification to ensure traceability. You'll also find the calibration date and the next due date, which helps keep your calibration schedule on track. The reference standards used during calibration, along with their traceability, are documented to show the basis of your measurements. Measurement results and any observed deviations are recorded here, providing a clear picture of how the instrument performed. The report also includes the uncertainty of measurement, which indicates the level of confidence in the results. Environmental conditions during calibration, like temperature and humidity, are noted because they can influence the accuracy. If any adjustments were performed, those details are included as well, ensuring full transparency. Finally, there's usually a compliance statement indicating whether the instrument passed or failed, or if it's within the acceptable tolerance range. Now, why is this important? Well, the calibration certificate provides concrete evidence of an instrument's accuracy and traceability, supporting quality assurance and audits. It also helps ensure that your operations are compliant with regulatory standards. The main objective here is to maintain transparent, verifiable, and reliable calibration records. This way, we can confidently demonstrate that our instruments meet the necessary standards, which ultimately supports the integrity of our entire measurement process. Now, let's take a closer look at the factors that can influence calibration accuracy. These are internal and external elements that we need to manage carefully to get reliable results. First, environmental conditions play a significant role. Variations in temperature, humidity, pressure, or even vibrations can affect the calibration process. It's important to control or account for these factors to maintain consistency. Next, the condition of the instrument itself is crucial. Wear and aging can cause drift, meaning the instrument may not perform as accurately over time. Mechanical or electronic components can also drift, so regular checks are essential. Reference standards are another key factor. Their accuracy, stability, and traceability directly impact calibration quality. Using high-quality standards that are properly maintained ensures our measurements are trustworthy. Operator skill is often overlooked, but it's vital. The expertise and handling practices of the calibration personnel can influence the results. Proper training and consistent procedures help minimize human errors. The measurement method we choose also matters. The technique and procedure followed should be appropriate for the instrument and the calibration goals. Consistency here ensures comparability over time. Frequency of calibration is another point. How often we calibrate affects accuracy. Too infrequent, and errors may go unnoticed. Too often, it can be unnecessary. Finding the right interval keeps measurements reliable without wasting resources. Loading effects refer to the interaction between the instrument and the system being measured. Sometimes, the act of measurement itself can influence the instrument's performance, So understanding this interaction helps us avoid skewed results. Finally, power supply variations can impact instrument performance. Fluctuations in power can cause instability, so ensuring a stable power source or using uninterruptible power supplies helps keep calibration consistent. The overall goal here is straightforward. By controlling these factors, we aim to minimize errors and produce calibration results that are accurate, consistent, and reliable. Each of these elements plays a part in ensuring our measurement system remains trustworthy and effective. So, in conclusion, calibration is a fundamental process that we can't overlook when it comes to measurement. It ensures that our instruments provide accurate, reliable, and consistent results every time. Essentially, by comparing our instruments to recognized standards and making the necessary adjustments, we're maintaining the integrity of our measurements across different applications. This process plays a vital role in quality assurance, helping us meet regulatory requirements and keeping our process control tight. It also ensures traceability to national and international standards, which is crucial for maintaining trust and consistency worldwide. Proper calibration practices help us minimize errors and reduce uncertainty, ultimately improving the overall performance of our systems. The key takeaway here is that calibration is essential for trustworthy measurements. It supports informed decision-making and helps us uphold high standards of accuracy and quality in everything we do. For further support, please don't hesitate to reach out. If you have any questions or need additional information, I'm here to help. Feel free to contact me through the provided channels. Thank you so much for your time and attention today. I appreciate your engagement and look forward to assisting you further.